Okay, let's try this out. Just recording for now. Let's see. Okay, so before solving today's problem, I want to go in and address some of the things I was thinking about. So one thing I was thinking about is, why don't we, instead of calling functions by name like this, we just call all functions that start with so we don't need these arguments. We're just gonna call every function. Let's get this out of, we're just gonna call every function that starts with that. So we don't need that. We don't need that. Call all functions that start with year. Okay. No arguments. It's not a bool, it's a void. Okay, starts with year, mixin. Okay, so mixin. Yeah, let's just do it the mixin way for now. Well, let's just debug it first. So pragma message. And what I want to do here is something like, God. That's temp. We're not returning anything. Okay, compile. Temp. Yeah, that's correct. Member. Does this work? Yeah, that works. Okay. Member. I mean, this would just be a call, right? It would just call it. Yeah. Well, kind of. Mixin member that. Wait, what's wrong here? Static cannot be read. Well, yeah. So what about this? No, I see. Yeah, so this thing is what becomes mixin. All right, so member. So this will just call it. We're not really interested in just calling it though. We want to also print like write to std out that member string of. Let's see, what does this do? Yeah, well, that's approximately what we want. Yeah, it just writes it to std out and then it calls it. Which is kind of what we want. Although, like this there's a bit too much going on here, so I maybe, is there a better way to like generate code like this than just to mix in? Maybe. Let's see. dlang meta, well, actually tour. Let's see, dlang tour. These gems, compile time, functional string mixins. Well, yeah, I mean that, I'm pretty much all over that. Unicode, bit manipulation, template metaprogramming. Let's see. If you ever got in touch with template metaprogramming, you'll be relieved. Yeah. Static ifs and is. Static if, yeah, is t equals int. Mixin template. Anywhere you see boilerplate, mixin template is your friend. Okay, so this is kind of what we want. Mixin template. Okay, so I guess mixin template is really what we want here. Mixin template. How do you do this? Name. Call a year function. Like something like this. Mixin template. And then we just write like normal code. Like okay, name. Okay, what's wrong with that? Function declaration without return type. No identifier for declarator name. Well, yeah, but like, so it takes in types. Mixin foo int. Directions are inserted at the instantiation point. Yeah, but I'm not calling it anywhere. Why? Like it's the template itself that's does that work? Yeah, that's okay. So that somehow works. If you just write T here. No identifier for declarated T. Well, I mean, yeah, but so what? Template constraints. STD traits. More templates. Yeah. The shortcut syntax. Yeah, so these are like types. Templates take types. Which is not really what I want. I want way more than that. So what's a mixin template then? Well, yeah, interface templates, mixin. We're looking for mixin template. Mixin temp. That's not even here. Mixin template. Oh, you do mixin to instantiate wait, but the template itself is erroring out. So that's just a parameter. Yeah. There's only one parameter list. You can only ever pass it a type. Like, yeah, it's a declarator. Like, it can't be. No identifier declarated T. Yay. Mixed in templates. Let's see. Local Y is picked up, not global Y. Call ABC, return cert. Mixin. Nixon. Right line. Bar B. Struct bar mixin foo. So index. Alias fun. No, so you can do. Okay, so what's an alias parameter? Compile time. Huh. Okay, so if we just do alias here, then no. No. Yeah, there we go. Alias fun. And then fun is just kind of called here. Okay, let's. So that's what happens here. Okay, so that compiles. Okay, so that compiles. Oh, so it defines a function. And it's inside the function that you use it. Mixin dev device, which then calls dev loop. Oh. Okay. Yeah, but that's not really what I want though. Like, I kind of want just this, but you know, with a better way to construct the string. Or maybe I don't want that. I don't know. Does this do anything? Kind of. Write to std out, call the function. Well, I mean, you call the function, but then the function should, I mean, I guess, well, sometimes there's multiple return values from these things. I mean, I guess the function can just print the thing. And like, there's no real... There's no real reason not to concatenate the strings at compile time. So, like, all we really want is to call the function probably, right? Like, we don't really want anything else happening. Makes sense. But even then, can't we just do member like that? No? Apparently this is a string. Somehow. Oh, because that returns a string. Yeah. Call all functions that start with year. Yeah. And that's it. And then for printing things, I mean, we could just do like something like this, right? I mean, I just want a compile time string concatenation. Like, why is that bad? Oh, so you can do that? Oh, yeah, that you can do that. Yeah, so each of these can just call that. And I mean, this, well, I mean, that's not so bad, I suppose. Just these two lines. I mean, this kind of boilerplate is what mixing templates is supposed to be solving, right? Presumably. Well, not really. Right, right, right. Okay, well, let's run that and see what happens. We crashed somewhere. Oh. Path. Input year 2023. They, oh, yeah, well, that's actually fine. Because we don't have the input for that. So let's get the input. And get your puzzle input. And save it in input. So this is year 2022, day 3. Okay, so that, I think that just worked. Yeah. Well, it worked as well as it could have worked. Yeah, you know, that setting where it attaches, let's not do that. So now I should create a new, yeah, that works. Okay, so that's one thing I wanted to do. Another thing I wanted to do is, well, actually, hold on. What's the output? app, app, app. Okay, well, yeah, we don't really care so much about that. That's that. Yeah. Okay, that this is what we want. That's fine. Okay. Yeah. What's the other thing I wanted to do that I didn't like here? This is fine. This is fine. Oh, it's arena. Yeah. So I wanted to actually do this. Long used. Okay. And use 0. Obviously. Use 0. I mean, I think it would allocate to that anyway. And we don't even really need this anymore, come to think of it. Alloc. Okay, so how would we alloc? We just would do buff arena used to size. To arena used plus size. And this arena used plus equals size. Well, not that. Long used arena used plus size. We slice it from used to new used, and then we do arena used equals new used. Okay, so there's bounds checking on this, is why that's good. We don't need that anymore. Circular buffer. If size is greater than, I mean, it's kind of useful to just know what the free size is. Free size. And we can do that pretty easily. Free size buff length minus used. And then used is 0, and then it's alloc on the arena. And that will fail if this is too much. Memory, yeah, that's fine, that's fine. Alloc, talloc, temp, null terminator. Yeah, I mean, there's no errors here anyway. Fumut, okay. Butter. Alright. Alloc. Yeah, I mean, it is nice to be able to get that as well. Void stuff, free putter is buff putter plus used. Yeah, that's fine. Arena free putter. Well, there's all the letters, yeah. So free length, that's just free size. Arena used plus equals, and here's actually, what did we do here? Size. Yeah, size, right? We have this. So global memory arena use plus equals size. And on operations like this, I would like to have extra bounds checks just in case. Because it's like super easy to get wrong. Free putter, free size, free size. Yeah. I mean, I don't know if that actually is correct, mind you, but yeah, it seems to be doing fine. Okay, so that's what I want to do with the arena. Yeah, used. So extra bounce checks on used. How do we do that? Let's actually commit what we've got. Focus on the primary sidebar. Change arena to buff used again. Control enter. Yeah, whatever. Tab. Yeah. Okay, that's fine. Now run tests, read entire file, alloc email. Can we insert extra bounce checks on used for the arena? So whenever we assign to it, it should check that it's the correct one. Well, let's find out if that's possible. Okay, so I think instructs it might tell us. Like you can do like properties, right? Attributes. There. Property bar. Okay, well, property used. So I'm guessing this isn't gonna work very well. Yeah. So and then and you just overload it. I see. Yeah, well, here's when I want to insert that bounce checks, right? So it's used equals new used, but only after the bounce check. So like assert new used is greater or equal to 0. Assert new used is less than or equal to buff length. So that. Oh, I mean, we can even just put commas here, presumably. Using the result of a comma expression is not allowed. Yeah, so we kind of have to. Yeah, semicolon like that. Well, might as well. Okay, so something like this. So this requires garbage collect? Wait, hold on. Yeah. So like this is fine. So there's going to be a bounce check here. There's also some kind of weird... That? Okay. What's this? Empty declaration? What? What empty declaration? Like that? Okay, so this way, well, let's see. So use just returns that, so that's fine. But used, like when you try to assign to it, does this. Now, okay, so I think in operator overload, can we just overload things? Bit manipulation. D operator overloading. Let's see. Operator overloading. Yeah, but that's like the whole struct that does that. Slice, cast, boolean, binary, comparison. Yeah, so it's the plus equals specifically that is not. Yeah, because you're modifying the element, so yeah. So you can assign it. So like you can't do a plus equals here. But what you can do is this. Like that's fine. Because there's bounce checks on it. So this is how you can insert bounce checks whenever there's an assignment to use, like here. Here. All of this should go away in optimized, presumably. You might as well just every time, you know. Might as well just call it every time. Can never have too many bounce checks. Let's see, does that still work? Yes. Wait. So it's loading the standard library, the C standard library. Even though when you look at dump, bin, abundance, build, yeah, so this says it doesn't actually depend on that. So that does the kernel depend on that? Is that what's happening? Maybe. Interesting. So when you exit, it loads app core and MSVC. But when you launch it, it doesn't. I see. Okay, well, whatever. Focus. add bounds checks to used assignment. Time 1352. Okay, now these functions, right? It's kind of nice to be able to run them on smaller inputs. Well, maybe. Although, maybe that's not so important. Maybe it's not so important. Okay, what's the problem again? Two large compartments. The elf that did the packing failed to follow this rule for exactly one item type per rucksack. The elves have made a list of all the items currently in each rucksack. Every item type is identified by single lowercase or uppercase letters. A given rucksack always has the same number of items in each of its two compartments. So the first half of the characters represents items in the first compartment. The second half, the character represents items in the second compartment. Every item type is identified by a single lowercase or uppercase letter. Okay, so each letter is a different item type. One of the two compartments. So like yeah, okay. The first rucksack contains the items, which means its first compartment contains the items. Second compartment contains the items. The only item type that appears in both is the lowercase p. Contains that and this. The only appears in both. Third appears in both. Every item type can be converted to priority. 26. Item rearrangement. Priorities 27 through 52. In the above example, the priority of the item type that appears in both is 16. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of those item types? Okay, so step one, well, we need to iterate over the lines again. Okay, line range. And for each line, whatever. Okay, well, there we go. Okay, so there's our lines. There's supposed line length. Line length is supposed to be mod 2, a multiple of 2. Otherwise, it just doesn't make sense. Long per compartment is line length divided by 2. This is like items per compartment. And now we need to iterate over both. So long comp1 is line 0 per compartment. Not long, string. And comp2 is line per compartment to line length. Okay. Now for long index is 0 index per compartment index. Char comp1 item is comp1 index, and comp2 is the same. Okay, comp1 item, comp2 item. Well, I mean, they're not necessarily in the same place, so we actually need to do this twice. Well, do we? No, not really. Because this is ASCII characters, right? So it's like... And it's all only characters. So it's 52. There's a total of 52 of these things. So all we need is just like a bool comp1 priorities 52. Well, can we put this into like a long unique priority count or something, or max priority 52. Can we do this? No. No. It's here. Well, const. Yeah, that works. Bool max priority comp1 priorities. And comp2 priorities is going to be the same. And then we iterate. These are the items. There's exactly one item that's misplaced, that's shared between the two of them. So all we gotta do here is we just gotta say char comp1 item, char comp2 item, long comp1 item priority get priority comp1 item, and same with comp2, and then comp1 item priorities, comp1 item priority is true, comp2 item priority. Okay, and let's just set those entries. Okay, long get priority char So if char is smaller or equal to lowercase z, then it's char minus a. Wait, it's char minus a plus 1, yeah. Otherwise, it's char minus z plus 27. So something like this. Z plus 27, okay. I suppose we need to like assert a and I mean, well, I could just do that here. So we're gonna call this anyway. Nay and char is less than z, or so that's that, or the same with capitals, like that. So these are the items, these are the priorities, we set that. Okay. Now we just iterate over the priorities. Priority equals 0, priorities less than max priority, priority plus plus, bool comp1 in comp1 is comp1 priorities priority, and this is in comp2. If in comp1 and in comp2, so if it is in both, then we want to sum, right? So like long shared items priority sum. Comp2 shared item priority sum plus equals priority. Bool found shared false found true assert. So I'm not gonna break here just to make sure that there's only one item like that. Right to std out format. Okay, what are we formatting? Just the number, honestly. Like that. Okay, let's see what happens here. Here, well, can we navigate to the appropriate file, please? No. Starts for some reason. Okay, now we can. Okay, well, let's see what happens here. Locals, yeah, let's just look at locals. Line is that F, okay, comp1, comp2. Comp1, comp2, yeah, that sounds about right. 23, length is 46. Max priority. Okay, so that is enabled. That's all good. Comp1 item, comp2 item. Comp1 item priority is 8, comp2 item priority minus 15. What? Comp2 item is Q. Did I? Oh, wait. Why am I subtracting Z? It's minus capital A plus 27. Actually, can we, like, there is a way to break it. All right, yeah. F10, F10. Okay, still minus 15. What? Less than or equal. Oh, wait. Uppercase is. Uppercase is after, right? In ASCII. Comp1 item. Wait, what? Wait, yeah, we haven't gone through that. 8 and 43. Yeah, so that sounds about right. It's the next one. Q and W, B and L. B and L. Okay, so Q and V, J and Z, S and V, Q, W, H, T, H, V, H, C, H, V, H, C, H, T. Okay. Let's see if we find the shared one. Oh, by the way, assert found shared. There we go. Okay, so we do fail. Let's see, where do we fail? Here, evidently. Comp2 item priority, 52. Oh. Yeah, so that's priority minus 1 technically, but yeah, it's kind of annoying to just have to constantly minus 1 everything. So max priority is that, but let's just add 1. Yeah, let's just add 1. The priority, yeah. Priority 0 is something we're just not using. Okay, so it output the 7674. Let's see, 7674. Yeah. Match is the only item type carried by all 3 elves. shouldn't be carrying any other item type. Only item type carried by all three. Okay. That is common between all three elves in each group. Every set of 3 lines is a single group, but each group can have a different badge item type. First 3 lines is that, and the second group rucksack at the next 3, and the second group at the next 3 lines, yeah. In all 3 priorities must still be found to organize the sticker attachment. 18, 52, the sum of these is 70. Find the item type that corresponds to the badge of each 3 elf group. What is the sum of the priorities? Okay, so now we're just looking for badges. Okay. Now we're just looking for badges. So we want, as we're iterating through the lines, so these are compartments. Yeah, okay. Well, we basically want this, but more of these. Max priority is that. So this is not, okay, this is like group line 1 priorities. This is group line 2 and group line 3, like that. And as we're iterating here, we just need to clear them occasionally. Yeah, we just need to occasionally clear them. Every 3 lines, in fact, we need to clear them. But really, we can just do that here, okay. This is compartment 1, this is compartment 2. I mean, as we're iterating through these compartments, like right here, we could just say, like, current group line. Actually, we don't really need these to be like 3 separate things, right? We could just have group line priorities like that. Just have 3 of those. And like long current group line index is 0. And then in here, we just go group line priorities, cure group line index, comp1 item priority is true, and comp2 item priority is true. So just set both of those for the line. And then at the end of this, if cure group line index is 2, then cure group line index is 0, and we need to clear it. So mem set, I guess, well, do we have mem set? No. Well, we must have mem set somewhere. We could probably have it here in string, right? Yeah. Character and okay, so it's something like group line priority 0, footer 0, and bytes, size and bytes. I mean, I should hope the size and bytes is just the size of the array, so like a 0 length. Well, I mean, I guess we can just do size of one of these things. It's wrong. Well, how do you figure out the size of something? D-lang size of properties. Oh, yeah, it's a property of the thing. Yeah, it's not a size of like that. Okay, what is going on here? Just for long I is less than group line priorities length I plus plus. I bool R is that. Yeah, that works out. So reset it. If it is 2, then reset it. And set these to 0. But before we do that, for long I is 0. Well, actually, prior. Well, it's the same kind of loop as I did here. Yeah. Well, actually, no, it's group line priorities 0 priority bool g1 2 3. Oh, well, I mean, okay, 0 1 2, sure. If g0 and g1 and g2 sum of keys, right? We're looking for sum of keys. Badges, yeah, badge sum. Okay, so this means it's a badge. So this means it's a badge, and we need to say here, we need to say, well, it's not found shared, it's found badge. Assert found badge. Assert found badge, like that. Found badge true. So something like this, approximately. Let's see. Okay, so group line priorities. There's 3 of them, and each of these is an array like that. Yeah, so this is a V8. Okay. So this is the first one, it's 8, and like 43. Okay, so this seems to be working out just fine. Let's, oh wait, we're not incrementing the index away. Else cure group line index plus equals 1. Let's step in here. Okay, so we're gonna iterate through these. So all these are false. All right, can we run until we find some? Yeah, so Q, well, not Q, but priority whatever 19 is that. So batch priority sum is 0, you add priority to that. Yeah, so we keep running. Let's make sure this works correctly. So R is that. Okay, so we're looking for these things. So all these things need to be reset. Well, they're not all meant to be the same. They're not all the same. That's good. Mem set. Yeah, that worked. Mem set. Mem set. Yes, that all worked out. Set to 0. Okay, well, we should be fine. 2805. 2805. Yeah. So that's good. Yeah, I mean, this is fine. Focus. Solve date.